Expressed in this form, this is a completing the square question. First things first. Actually, let me just write the thing down. 2x squared minus 20 for x plus 80. Right, first things first, take the 2 out. Factorize the 2 out of the first two expressions. So we get x squared minus 12x. No need to factorize it out of the 80. We know in the final answer we've got a plus c, so this is going to form part of that. Now, we complete the square on x squared minus 12x. So to do this, we're going to get x minus 6 all squared minus 36. What we do is we have that minus 12. I'm not going to go into details well, I'll talk a little bit about it. Have that minus 12, and then think about what we get. And when I expand this bracket back out, I would get x squared minus 12x by me doing cross multiplying. Don't forget this is this. So I'd get my minus 12x, I get x squared minus 12x, but then I'm going to get plus 36. So I need to minus the 36 because of that. There is a geometrical way of showing this, but I'm explaining it algebraically. I then need to add the 80 on. Okay, then pull it together. So it's going to become 2x minus 6 all squared minus 2 times minus 36, that's minus 72, plus 80, and we're nearly done. 2x minus 6 all squared plus 8. Fantastic. That's the hardest bit of this question. So state the equation of the line of symmetry of the curve. Okay, it's just going to remind you of a couple of things. When we complete the square, I don't know if it looks exactly like this. This is just a general quadratic, but when we complete the square, we actually get the turning point for free. We know the turning point is going to the minimum is going to be 8 when x is 6. So this is definitely not a correct sketch, but it still gives the right idea. That's going to be my turning point. The line of symmetry then looks like this. It actually goes through the minimum and is vertical. So I want the equation of that line, and it's going to be essentially the value of x at the turning point. So it's simply going to be x equals 6. Part 3 then says state the equation of the tangent at its minimum point, and it's a similar sort of idea. A tangent is a straight line that just glances off of a curve. So this one doesn't quite. I need to bring it up, and now it does. So this is going to be a y equals line because it's horizontal, and it's going to be y equals the minimum. This value of y is always going to be y equals 8. So by completing the square, we're able to solve the quadratic. That's one thing you can do potentially. In this case, it wouldn't actually have any real roots, but you also get the line of symmetry, the minimum or maximum, and we get the tangent.